Hi, welcome to this special episode of ThursdAI, which I'm very excited to bring you on Sundays. Sundays will be our special episode time. I'm Alex Volkov, the host of ThursdAI and the founder of Targum Video. I want to thank you for subscribing, and I hope you enjoyed this one. However, it's important to note that I'm not a data scientist, and much of what you will hear in this special deep dive is new to me as well. I'm recording this on August 18th, which marks the 1-month birthday of the Llama 2 release from Meta. It was the first commercially licensed large language model of its size and quality, and we want to thank the great folks at Meta AI, Jan LeCun, Vic Zak, and the whole FAIR team. Thank you guys. It's been an incredible month since it was released. We saw a Cambrian explosion of open source communities who make this model better, even since Llama 1. For example, LLaMa.Cpp by Georgi Gerganov is such an incredible example of how open source community comes together, and this one guy in a weekend took the open source weights and made it run on CPUs and much faster. Mark Zuckerberg even talked about this, how amazing the open source community has adopted Llama, and that Meta is also now adopting many of those techniques and developments back to run their own models cheaper and faster. And so it's been exactly 1 month since Llama 2 was released, and literally every ThursdAI since then, we have covered a new state-of-the-art model, all based on Llama 2, that topped the open source model charts on Hugging Face. Many of these top models were fine-tuned by Discord organizations of super smart folks who just like to work together in the open and open source their work. Many of whom are great friends of the pod. News Research, with whom we've had a special episode a couple of weeks back. Teknium seems to be part of Ariel org. Alignment Labs and GarageBand being the last few folks topping the charts. And so I'm very excited not to only bring you an interview with Alignment Labs and GarageBand, but also to give you a hint of 2 additional very exciting efforts that are happening in some of these discords. I also want to highlight how many of those folks do not have data scientist backgrounds. Some of them do. So we had a few PhDs or PhD studies folks, but some of them studied all of this at home with the help of GPT-4, and some of them even connected via ThursdAI community and space, which I'm personally very happy about. So this special episode has 2 parts. The first part, we're going to talk with Ariel, Cole, and Nathaniel, currently known as GarageBand. Get it? GarageBand, because they're doing AI in their garage. I love it. Who are now holding the record for the best performing open source model called Platypus 70B Instruct, and several other of the top 10 places. And then joining them is Austin from Alignment Labs, the authors of OpenOrca, also a top performing model, that will talk about how they've merged and joined forces and trained the best performing 13B model called Platypus Orca, or OrctyPus 13B. This 13B parameters model comes very close to the base Llama 70B. So I will say this again. A month after Llama 2 released by the great folks at Meta, we now have a 13 billion parameters model, which is way smaller and cheaper to run, just a month after, that comes very close to the performance benchmarks of a way bigger, very expensive to train and run 70B model. And I find it incredible. And we've only just started. It's been a month. And so the second part, you will hear about 2 additional efforts. One run by Ariel, Prateek, and Alpai from the Skunks Works OS Discord, which is an effort to bring everyone an open source mixture of experts model, and you'll hear about what mixture of experts is. And another effort run by friend of the pod Teknium, previously a chart topper himself with News Hermes models and many others, to figure out which of the fine-tuning methods are the most efficient and fast and cheap to run. You will hear several mentions of LoRa's, which stand for low rank adaptation, which are basically methods of keeping the huge weights of Llama and other models frozen and retrain and fine-tune, align some specific parts of it with new data, which is a method we know from diffusion world, and it's now applying to the LLM world and is showing great promise in how fast, easy, and cheap it is to fine-tune these huge models with significantly less hardware costs and time. Specifically, Nathaniel Ruiz, the guy who helped Ariel and Cole to train Platypus, and you'll hear from him as well, mentioned that it takes around 5 hours on a single A100 GPU to train, or I guess to fine-tune the 13B parameter model. That, if you can find an A100 GPU, that's around $10. That's incredible. And I will just briefly mention that if you're interested in fine-tuning, please join the ThursdAI spaces on our new website, ThursdAI.news, as we'll be releasing updates from these team members. And with that, I give you the interview with Ariel, Cole, and Nathaniel, who are current leaders in open source LLMs. Cole and Ariel, the authors of Platypus, who shot to the top of the charts, I think, super quickly. And yeah, just say hi and kind of introduce yourself. Where are you from and how you found yourself to the top of the charts in the open source LLM world.
Hey everybody, I'm Cole, part of the Platypus team. So we've been at BU just working on some of the LLM stuff. Like people were saying earlier, we were interested in seeing how effective the LoRa's could be in terms of imparting domain knowledge. So that's kind of been our focus for the time being.
Yep, my name is Ariel. I'm from California originally. So like Cole said, we kind of started working on some group projects together in school and got lucky as teammates. And I worked with Nathaniel on a previous paper. So kind of towards the end of school, as we were still students working on that paper, I started talking to him about LLM stuff because, I mean, as you all know, it's so prevalent, and I feel like it really is the space to be in right now.
Absolutely. And I want to also welcome Nathaniel as well. Look, Nathaniel, feel free to introduce yourself and some of the stuff that you worked on, because this is your first time in ThursdAI space.
Yeah, hi. Can you hear me?
Yes, we can hear you fine.
All right, great. Yeah, so sorry for this impromptu joining. I'm working, but I do have a couple of minutes to talk about this. So hi, thank you so much for inviting us to talk here. And just wanted to introduce the students basically and the work we've been doing. So mostly I did most of my work during my PhD and at Google now is on computer vision and now generative AI for computer vision. I have not worked too much on the language space, but I've always been kind of like tangentially interested in it. And then Ariel mostly has been like the driving force to get me towards, being interested in this space. So I have to say, like, all the credit is to Ariel and Cole for doing all the really hard work for this project. Mostly I was like guiding in terms of like advising and kind of like writing and all of that stuff, where they're starting to have more experience. But yeah, I kind of like deferred to them and all the questions relating to the language models, and I'm still learning. I think they know more than me at this point. So yeah, welcome Ariel. Both of them did a master's at BU, if I'm not mistaken, and now also they're available for hire. They just graduated, and I think like they're unbelievably good students. It's really hard to find students that are so hardworking.
That's awesome. Nathaniel, thanks for joining. And I want to just say to the folks that, Nathaniel is humble. He's the co-author of Dreamwolf, is that correct? From the diffusion world, and also Style Drop recently. Nathaniel, just before you joined, we've talked about the cross-pollination of ideas with YAM and how ideas from the diffusion world, like LoRa's are being shared. And I think I've added a tweet on top that folks are sharing LoRa's with LoRa the Explorer, a new project that people can just share different like concepts, which is super cool. CFG is another idea from Stable Diffusion, how those are like transferring to the open source LLM world. I'll ask Ariel or Cole, feel free to pick this up, is that how much of this kind of work from that area helped inspire the work on Platypus?
So I think like you were saying with the Stable Diffusion stuff, in terms of the LoRa's, one of the things you really don't want to have to do is if you have specific information that you want to track, you don't want to have to do another full fine tune. And then in a lot of cases, you might lose some of the base information. So that's kind of where the main idea came from, right? Like you want to keep the strengths that are already pre-trained into the models, specifically Llama 2, and then just build on top of that without kind of degrading the quality that's already there.
Yeah, and then kind of going back to Nathaniel's last paper, or maybe his second to last paper, Hyper Dream Booth, that was some of what kind of inspired us, like that he used LoRa so successfully. And I think he did like relaxed rank fine tuning, and just the success of that in general, it speaks volumes, I think, to like how much progress we can make in this space.
Absolutely. And you guys obviously like shown great results with I wanted to ask about the name as well. I think GarageBand, is that the name of the org? I saw this somewhere. I found it really funny because of the ThursdAI also using it.
Yes. I'm so glad you liked it. We were going back and forth, like maybe it's kind of lame because we created it, not ChatGPT, surprisingly. But we thought it was like really cool. And we basically are sitting in our garages, like trying to do this anyway. So yeah, I'm glad you liked
So
it.
we heard a little bit of the backstory and kind of how LoRa's help. You also released a data set as well, right? Could you talk about this a little bit as well?
Yeah, so that was mostly just trying to go through and figure out the quality of the data going into the models is the most important thing. Specifically for us, we were interested in looking at kind of STEM and logic. So it was just going through and trying to find things that would cover that without being too expansive. I think in the paper we mentioned, we were kind of going off the idea that LLaMa showed you can use like a really small subset of questions to get good alignment. And then also in the Llama 2 paper, it had mentioned that they hadn't really reached saturation in terms of the training. So we were thinking if we could try and bridge that gap, right? So you have a not tiny data set, but also one that's not too expansive so that the training isn't too long. So we just kind of pulled from different open source data sets in a way to kind of build.
And I want to say some data sets also by folks who are friends of the pod here and here on stage, if I'm not mistaken, correct?
Yeah, I
That's
believe
awesome.
so.
And so you use like, and you also released kind of the mixture. And tell us like what sets it apart from the other models that we've seen kind of on the topping those charts. What sets Platypus apart and why is it better?
So I think one of the things is that because it's very specific, right? Like the adapter itself, we only trained on, I think it was 25,000 data points, and then it's specific to kind of a single topic. The merges ended up doing better, right? Because we tested it on the broader ones. So there's like the OpenOrca, and then there's also the ones, I think it was the Camel one, which is the medical specific one. So generally speaking, you would have improvements, but the ones where it was you're taking the kind of small subset and then putting that on top of the also broad pre-train, those had the best results instead of just going with a broad pre-train as the base.
We also looked at like, as to the best of our abilities for the open source data sets that are out. We looked at other models and kind of tried to compare how similar our questions were to their fine-tuning questions when we were merging a fine-tune. And definitely we saw that questions with like less similarity, at least embedding wise, the models that had less similar questions, those merges are the ones that did a lot better.
And so additional thing I saw, at least in Nathaniel's kind of announcement thread, about this being cheaper to run or faster to run on like smaller hardware.
Sure. So one of the advantages being, I think that this is also what the mixture of extras people are kind of shooting for, right? So instead of having to have all these huge models, if you can do the LoRa trains on a bunch of different data sets, then you can kind of have an expert in all these different areas instead of having to do a full fine tune to get to that point. So being able to kind of just, one, you can get through the training faster, and then you can do the evals faster. So I think it just gives you a little bit more room to work with iterating through different data sets and kind of experts that you're shooting for.
Also, during inference itself, right, it just makes more sense to load the adapters, load the base model once, and then just load adapters, right? Like it's much more memory efficient that way.
Yeah, because then you can just, right, you can basically just say, okay, for a given question, you want to load this adapter or that adapter instead of having to kind of have all those things running on RAM for different models.
So first of all, guys, kudos on the incredible work here. Topping the chart like really quick, and we expect to see way more. So can you talk about like the different sizes that you released? I think the top chart right now is Platypus 70B Instruct, but also like following this is the regular 70B. Could you talk about like the different models that you've kind of trained and released, and then we're gonna talk about the next collab.
Sure. Yeah. So for both, we did a 13B and a 70B kind of pre-training or using the Llama 2 as the base. And then all of the merges themselves are actually LoRa merges. They're not like the both models being merged together. I think someone had mentioned they thought that was the setup before, but it's all adapter merges on top of the existing models.
And the instruct model, how can you talk about how it differs? It's just like based on the Llama instruct?
Yeah.
Awesome. Okay. So I want to also introduce, while he was coming up on stage, I want to introduce Lyman Lab. Lyman Lab, feel free to unmute yourself and talk to us and give a brief introduction. And then there's something very exciting that I saw that also kind of connects to the Platypus team. So feel free to introduce yourself briefly, and then we're going to ask some questions.
Hi, my name's Austin. Alignment Labs is kind of like a loose term at the moment. I don't know that we've actually got like a solid name down. We're working on a whole bunch of projects. I think notably right now, OpenOrca is getting the most attention. And also we're just kind of not announcing everything all at once. But yeah, that's really it. It's really mainly just everyone else that makes our stuff super good, but everyone else likes to work together. And, I'm trying to facilitate that as much as possible.
So Austin, so first of all, welcome. We've talked about OpenOrca last ThursdAI, so folks who are interested, definitely there's at least some conversation about it there. And OpenOrca is an open source replication of the Orca model from Microsoft, I want to say, right? And Austin, can you tell us about your background? You told me, and I found it very interesting. So I'd like this on record.
Oh yeah, no, I'm not professionally like affiliated with AI from before Alignment Labs. I mainly come from a diverse background of a lot of vape and smoke shops. But really, I mean, it's mostly just because I trended towards picking jobs that would let me kind of sit at home and study, or go to work and study by myself, not get harassed by a boss.
And how did you get to find the new models from there?
GPT-4 taught me. I had an interest already. I was kind of like sucked in around the time stability was really picking up. And, at the time I was really into image models, but then GPT-4 took my attention. And, after that, that's all I've been doing.
The reason I asked is mostly to kind of highlight how incredibly fast this field is moving. And Austin, you're not the only one like this on stage here at ThursdAI. There's many folks, Junaid namely, and there's some other folks who are new to the field, and it allowed them, like GPT-4 and some other like things, allowed them both to get excited about the field, but also use these tools to kind of self-teach themselves as well. And I find it very exciting that we have folks, veterans of machine learning, who are now diving deep like Yam, and also folks who are completely kind of new to this and are also exciting and doing like great strides. So huge kudos on this, man. And I bring this up to inspire other folks who are like maybe thinking maybe this is not for them, or maybe this is like above their head. Go into the Discord, talk to these folks. There's like a great community happening that like Austin, I think you told me like it's very addicting. If I to get started, I never find to anything myself beyond maybe some dream booths models or textual inversion models, but definitely folks should try and should help the community.
I think when you've done it a couple of times and then you realize that the biggest like thing that's like not that needs to be done in terms of advancement is just 100% like it's creativity. It's more like, how can I make this data set better? Just putting pieces together more than it is. I mean, no, not to say more than it is anything excessively technical. It's all super technical, but I don't know. It is addicting though, because it's not. I think it's not as dry as people see it from the outside. But I think there's also a reason why there's so many people who are extra interested in data now, as dry as that term is. But it's kind of the coolest thing in the world.
I love your excitement. I think it's infectious. And now I want to like go back to Cole and Ariel. And so you and the Lyman Lab have a collaboration, right? So could you talk about like how you guys found each other, and then could you talk about Orca, Platypus, OrctyPus, or whatever we're calling this now? Please give us a brief intro of how you guys met, and now like what is the kind of the outcome of this collaboration?
So when we put everything out, they reached out and was just interested in the work. So we hopped in the Discord, and then we were just talking about what we could do with both of the kind of the data that we have and also the data that they've got. So we also did a merge with the OpenOrca, I think it's Preview 2, right? To good results. So that's currently the best 13B model. I think there should be a Hugging Face space where you can go and chat with it as well. yeah.
The OpenOrca collab with Platypus is the 13 billion model, right? And it now is better than the 65 billion model. Is that what I'm hearing?
Yes.
That's incredible, and it's incredible specifically because like the speed with which things are happening. I don't know if Llama 2 was released even a month ago. I think like it's around a month ago. I don't know if a month has passed since then, and since then, which is like seeing significant jump in its capabilities. So you said you merged together with the Orca. This was a model merge, or was also the previous merge that you've talked about?
No, also the same kind of lore merge. So it wasn't a model merge itself. It was using the adapter from the Platypus Finetuning.
That's super cool. And Austin, feel free to chime in here as well. You reached out to those guys. What do you see that kind of new that they brought to the table that kind of helped the 13B model to top the rest of the models, way bigger models as well?
So, I mean, I think there's a lot of things involved. But I mean, really, in particular, it's what Cole was talking about earlier, where it's become good at diverse things that aren't overlapping each other, and I think it's the overlapping topics that tend to cause a lot of the damage to the models that occurs when you give them multiple fine tunes or start merging together. And we just happen to have a few people that were already focused on that on hand, and a really, really good model to start with. So, I mean, I think probably they figured out that the merge was better. In fact, I'm quite sure that they knew that merge was going to be really, really good before we did.
That's incredible. Yam, go ahead.
I just want to say there are a couple of things that need to be said. First, anyone that still doesn't believe that small models can be powerful, well, feel free to have your own thought about this. I know that many people have this belief that scale is all you need, or no matter what you do, people can scale. Okay, fine. You can have a small model that is extremely powerful, and I can tell you, I will release it in the future, but you can have a much more powerful model, much smaller. Okay, so it go there. Another thing that I would like to address is ensemble. Those ensembling models always make them better. If you need to ask me, like, what is the one thing that without thinking anything, like that will for sure make your model better? Ensemble. So I think that this is a good example for ensembling, and the people on the stable diffusion side are doing a lot of ensembling tricks, and I really like that we start to see it here as well. With this and with the merging of model sizes that don't exist, people merge models and create new size categories that didn't exist before in the middle. And this is another good example for a powerful model that you can do with ensembling. But I think that one of the most important things about this model that we should ask about is, how did you come up with the data? I mean, I know that you filter for high quality, but what exactly is high quality? How do you decide, okay, now we need to filter this data set for this and that, apart from deduplication, which is important, but we know about. Like what exactly, how did it work? What did you see and what did you decide to do after you saw it, if it makes sense?
Yeah, so I was just going to say, so the main thing was when we first started, we were just looking at focusing on STEM and logic. But even going through that, one of the things that we saw was that you needed to have kind of diversity in the types of outputs that you had. So the inputs could come in, right? You need them in instruction format. But there was an advantage to having not differently formatted, but sometimes reformatted questions or reformatted outputs given the data. So sometimes if you would just constantly have STEM questions that were also multiple choice, and it just gives you, okay, B, C, D, A, and you do that over and over and over again, it kind of degraded the quality of the outputs. So what we ended up doing was taking, for some of the data sets, was kind of augmenting the outputs to try and give it a little bit more diversity in terms of how it would respond. And that ended up helping the models.
This is smart.
Yeah, we also
really smart.
We also think that a huge part of the reason that the data set was so successful. I don't know if you guys have heard of PRM 800K. It's like the math, it's OpenAI's math, souped up math data set where they've essentially broken down all of the questions into step by step. And we think that's a huge part of it, is having really detailed and long answers, so that you can really break it down for the model. We think that might also be the secret. Like hypothetically, if you could have a whole data set that's just step by step, like I'd be really curious to see. I mean, OpenAI had huge success with GPT-4 just using step by step in math. So I think
how did you structure it? I know how it looks, but you got all the steps. How exactly did you build it? So I'm asking so we can do it for many other data sets.
For which one specifically? For PRM?
Yeah, let's say that I have a step-by-step data set of a completely different topic, and now I want to do the same thing.
So for PRM, the way that they'd set it up was, I think it is 800,000. Of those, some of them ended up at the wrong question. So we filtered for only ending up at the right question, or sorry, the right answer to the question. And then also, depending on the question type, there would be different outputs. So you could have, for each step, there was different, how do you say it? Different options per step. So what we ended up doing is we would randomly select a correct step for each step and use that to kind of build up a chain of correct thoughts getting to a final answer. That was specific to PRM.
Yeah. So you took only the successful ones. This is like Guanaco. Okay.
Yes.
This is cool. I just want to say we somehow need to be able to take the wrong one as well. I don't know how, just because it's a really powerful signal to the model what not to say. But yeah, absolutely. If we can, when we are going to augment other data sets with step-by-step tricks like this, it's going to be extremely powerful. So
Absolutely.
Yeah, it makes sense. Yeah.
And we put if anyone's interested, we put all of our data pipeline code on our GitHub repo, and we're also going to release a script soon that basically takes all 11 data sets that we use and creates Open Platypus so people can play around with that and like create different versions and all that fun stuff.
Want to mention one thing that is extremely important. It's extremely unintuitive, the way those models learn. They are not like normal machine learning because they predict for each token. It doesn't feel this way, but they predict for each token. So things like you said, that you have multiple choice questions, even the fact that the questions are A, B, C, and D, or 1, 2, 3, and 4, it makes a difference, that thing. And it doesn't feel this way. It's so unintuitive. And this is the thing that people say about deduplication is mostly because if you look at this in the lens of machine learning, it's because the classes are in balance. You have tokens that are extremely, extremely, extremely more frequent than the others. And I encourage everyone to plot the frequency of tokens after everything is tokenized, just so you can see for yourself how incredibly hard it is actually to learn this. It's just the representation of the data is so inefficient and hard today. So this is why the whole deduplication and the thing that we do really needs to be done. So yeah, just wanted to give a little bit of explanation about this, because it took me a while to understand why is this the case? How come machine learning doesn't benefit from more data? It's like, that's not the type of machine learning I know. What's going on? So yeah, that's the reason.
So I want to ask Colin, Ariel, and also Lyman, feel free to kind of join. So you guys released your own models. Then the 13B was an addition of both models. I do want to shout out again that what Nathaniel said. You guys are like finishing up school and you're now interviewing as well, right? So feel free to kind of say what you're looking for. Maybe some folks in the community can reach out to you and how they can find you. And then we can talk about what's next for GarageBand. And I want to add Nathaniel back.
Yeah, absolutely. I mean, yeah, we've been having so much fun this summer. It honestly started kind of as more of an intuitive thing. What would be the best thing to explore to make these LLMs work cheaper, faster and all of that fun stuff. And now we would just love to keep doing exactly what we're doing, but get paid for it. That would be the A+ move, essentially. So fine tuning, merging, advanced merging techniques. Maybe we'd be really curious to see how like ordered learning does, especially in the vein of experts. You take curriculum from like kindergarten to the end of high school, and you have that as your base, and then you continue with your experts in different veins, like you would different majors. Because I know generally speaking, we always shuffle our data, right? That's like one of the better things to do. But I'd be curious if you could structure it exactly how the curriculum is structured in 1 year. And, it would only see all of those questions once, right? Just like you normally would if you were taking particular classes, etc. So.
Yeah, I guess I'll also chime in. A similar vein, it would be great to keep working on the kind of stuff that we've been working on. I think there's a lot of room to improve as well, especially like Jan was mentioning. I think the data is kind of going to be key in trying to figure out the best ways to structure and handle that is probably where you're going to see the best improvements moving forward.
Especially since, it's when we break it down, it's a linear merge, it's additive. So kind of logically, like it feels a little bit backwards, but it works so well. And that has got to be like a data contribution. So we'd also like to look at, breaking down layer by layer, what's going on, maybe doing a TSNE on the weights and seeing if they're in the same space and all that fun stuff.
And so I will encourage the listeners to ThursdAI to check out Platypus work and kind of the stuff that Ariel and Cole released, and definitely give them a shout if you're looking for folks who can creatively help you run your models and fine tune them for better purposes. What I found exciting about all of this is this, first of all, like Lyman said, you guys are finishing up school, right, as well, but it's not like you have a decade working on this. It's exciting how much work can be done by folks who are like fairly new and just like excited and exploring different opportunities. Like Yam said, there's a bunch of data stuff that can happen, and folks from different backgrounds even can contribute. And also, I find it personally incredible that kind of the open source community just lifts everybody up together and kind of joined. And I know you guys have joined the MOE and the Ablation studies efforts, at least partly as well. And folks are asking kind of cross-pollination of ideas. And if ThursdAI is any help in this, then, we'll continue to be, and folks can join on stage and talk about collaboration and ask for suggestions as well. Daniel, feel free to kind of chime in here and to talk up to your students, man.
Yeah, sure. Yeah, no, I don't have that much to add. I just wanted to thank you for the invitation, and this like space is really, really cool. I actually didn't know it was, this cool. So I'll be joining more often, and just want to, congratulate the students on their amazing work. It's just, it really is impressive to me that, two students can start doing some independent work and kind of like even fund their own work, in some sense, and then get some amazing results that other people that are in the industry are not getting. So that's really cool. It kind of speaks to what Jan was saying, that the data is so important, and there's so many kind of little tricks that we can find to make the data better and get like smaller and smaller models. And I have some questions for Jan, but I'll take them offline.
Thanks for joining, folks. Again, huge kudos on the release, guys. Huge kudos on topping the charts. Always welcome to come in back to ThursdAI and talk about the new stuff that you're doing.
Thank you so much. Thanks for inviting us, and also to everyone who's included us in all the amazing stuff that's going on with Alignment Lab and OpenOrca. It's such a cool community to be a part of. So thank you. Thank you so much.
Yeah, thanks for having us.
I think we had a question from the audience, if you guys don't mind.
Yes, just very quickly. Is there any effect about or any ideas about copyrighted data sets? As I heard, you were using Llama 2, correct?
Yes.
Yes,
the basic.
Are you using any, let's say, copyrighted data?
No, absolutely not. Yeah, all of the data, at least as far as we know, all of the 11 data sets are open source. And there's just like, I think the most stringent license we saw was like non-commercial SA 4.0, something in that vein. So yeah, everything that we use to train our models, like all of the data is up, and it comes all from those particular data sets that we referenced.
So the same is true for OpenOrca. It's just FLAN.
Excellent. And also, at least you can use public domain type of information. That could be a plus.
I just want to say on this topic, one of the secrets, the secret sauce, it's not confirmed, but probably the difference that everyone sees between the open source models and the closed source models have something to do with this. Okay, it's not confirmed, but it just feels this way, that the model had seen extremely high quality text that somehow is not present in the open data sets. Okay, and I'm just saying, all right.
Yeah, I completely agree. And like think there's all this super high quality data in the pre-training for sure that we just need to bring out the right behaviors in the model so it knows to actually, like leverage that data that it might have forgotten a way that it had before. Yeah.
Wow, what a great interview. I want to briefly apologize for the sound quality. The AI world may be great, but it's not there yet to fix poor audio from Twitter Spaces. However, we will get better. There are methods. And I want to thank Ariel, Cole, Nathaniel, Austin from Alignment, and everybody else who participated in this interview. And we can't wait to hear more stuff. And I am very happy to call them all friends of the pod, and you will hear more of their work in next episode. The second part starts with a interview with Prateek Yadav, part of the Skunks, Quarks, OS, and MOE efforts group. It's a fairly in-depth interview, after which we'll hear from Ariel and Teknium about the different efforts on those topics. And now I bring you Prateek Yadav. Hey Prateek, you're welcome to chime into this discussion. Tell us about, maybe give us like a 2 minutes of what a LoRa is, and then how merging them helps get models better.
Yeah, okay. So hello everyone. So I'm Prateek. So I have been like working on machine learning, deep learning for like 6 years now almost. I started out in like 2017. Currently I'm doing my PhD in machine learning AI, working on similar things like mixture of experts in like merging models basically. So yeah, so on merging, okay, maybe I'll just give like a quick overview of what a LoRa is. So LoRa is basically like one of these parameter efficient fine-tuning methods. Initially, they were mostly designed because people did not want to fine-tune like full models. It was like overly expensive, and people didn't. If you don't have enough data for a task, then if you fine-tune a full model on that, it just like overfits severely. So you wanted like lesser parameters to fine-tune if you have a smaller amount of data, and also like you wanted to do it like cheaply without less memory and stuff, so that it's accessible. So that's how it started. And so LoRa is like just one of the ways of parameter efficient fine-tuning. There are like multiple others. There are like adapters, there are compactor, hyper compactor, something called hyper compactor, I8C. So there are like multiple other ways. So I think LoRa is the one which is the most popular and it's like most used by people. But like just to like put it out there, like other ways. So how LoRa works is as I was asked to describe it. So basically like you take the linear layers of the model, and what you do is you basically learn another set of weights, which are like which basically comprise of two matrix. One of them is a down projection, the other one is an up projection, and you just learn these weights such that. So what you do is you pass your model activation through the main linear layer, and then you pass it in parallel through these like two down projection and up projection layer, and then you basically add those things together. So basically, it's just trying to learn in some sense what weights need to be added to your linear layer such that it can learn this new task. So, and when people say like merging LoRa's, it's essentially, there are two ways you can have LoRa implemented. One of them is basically you can have your linear layer, and then you can have these other two weights like LoRa A, LoRa B, and you can pass your input activation through them parallelly and then add it at the end. Or because these are linear layers, you can just add these matrices directly to each other to have a new single linear layer. So when people say like merging LoRa's, what they mean is basically they just like take LoRa A, LoRa B, they multiply them together to get a bigger matrix, which is like D cross D something, and then they just add it to the linear layer where the LoRa was added, so that they don't have like two parallel paths. So this is what merging means in the context of LoRa. But there's like another type of merging, which is like merging like completely different models. So I think like recently there has been like a lot of confusion on like what merging means. Some people, when they say merging, they mean like merging the LoRa weights to the base model. And some other people actually mean like merging two completely different models to like combine their abilities.
please feel free to stay around because I know some of the next things we're going to talk about, you're at least a participant, if not one of the figures on there. Meanwhile, we have Pharrell on stage and Jan, and I want to check in with two efforts from the open source community that are running kind of in parallel in some similar places. And first of all, we have the MOE effort, which is happening in the Skunks Quarks OS Discord. And can you give us maybe a brief summary of what MOE is for folks who, for them, this is the first time they're hearing this concept? And then also, how is it going? What we should expect and when?
If you want to summarize it in one sentence, the big players are using MOE to train much larger networks, much larger models, using the same compute power, basically. In just simplifying things, but the way it works is during the actual training, you choose which parts of the model to use. So basically, you are using much less compute because you are not using the whole model, and it's all dynamic. So at the end of the day, you are training a huge model, but with a small compute budget.
It doesn't matter how we know this, but we know this, that GPT-4 is a mixture of experts model, correct?
Well, that's the rumor, at least, is that it's 8 times 200 billion parameter models. And I think Neston in a previous conversation had mentioned that they might have like a decoder layer after that. So in general, MOEs it's just like a category, right? Like there's so many different architectures that can be implemented to create a form of MOE. And in our case, well, we started this project, Prateek and I and a few others, where we thought, okay, how about we implement an MOE, but instead of multiple full models, we're using LoRa's or QLoRa's in our case to switch between different experts, right? And we're still building this architecture. We've got V1 pretty much completed. We're going to V2 exploring different architecture designs to be able to see how we can beat a base model, like a single, let's say 7 billion parameter Llama 2, by adding these different experts and removing them in different intensities. So we're merging and unmerging adapters, the LoRa adapters, during inference dynamically. And the hypothesis is that we can achieve a much better performance from these models or from this architecture. And there's a lot of different papers that you can check out if you're interested to learn more about MOEs. There's the branch train merge, the CBTM paper, which also uses a form of unsupervised learning or unsupervised kind of clustering of the data set and then training experts on those data sets. Again, Prateek also has a lot more knowledge on that front because he has worked in this field in his PhD. So if he wants to touch upon that would be great as well. But yeah, if anyone's interested to learn more, we have a Discord server called the OS Skunkworks, where we're doing a bunch of different open source projects.
Yeah, just very quickly for the audience. Mixture of experts is the architecture that makes GPT-4 so good. And this is like the holy grail now. And we call it like an open source Manhattan project, basically, because if we get this to work, the moat dries up really fast and you can make much better. Like the idea is that you can make it even a lot better than GPT-4 because you can have 64 experts. You can have an expert that specializes just in CSS or JavaScript or just Go. And then you can stack them up and scale them in all types of ways that you want. However, there are still quite a lot of unknown variables. I, for one, don't know how the training side of it works. I think I have a pretty good understanding on how they are doing the inference. I don't know how close the community is. It might be really close. It might still take another year or two to figure it out.
No, not another year. Listen, not another year. We'll figure it out probably in the next few weeks. We'll have a SOTA and we'll break this cycle.
Referral, feel free to kind of shout out what you need. If you need like support and resources, folks in the audience want to support you, or people joining, feel free to just like, invite support.
Yeah, right now we're scaling everything on the expert front. So we're expanding our data set significantly. We're basically consolidating all the data sets we can find and then processing them and cleaning them to have a really high quality data set that we can train our experts on. So anyone who wants to help on data set front, there's a lot of work there. We have a lot of efforts that on the architecture design as well. So we're exploring different ways to implement MOEs from switch transformer models to CBTMs to so on to really like hone in on the most performant architecture for MOEs. And at this point, so we're planning to open source like it's all open source, but we're planning to release the repo publicly for V1 of the MOE, which we're hoping can also be a kind of a springboard for others to explore different architectures and experiment beyond that. Also, all the experts we train and so forth are also available for you to experiment with when we release the repo. We're also looking for compute, right? So this entire skunkworks group, we want to scale up so many different efforts, and we'll talk about the ablation studies in a bit. There's a lot of different experiments, a lot of different things we want to try, and we're bottlenecked by compute. So if we can get access to more on-demand compute, we do have a decent amount of compute right now, but that can always be better for sure.
Awesome. And so for folks who want to join,
Give us all your
and
GPUs.
give those GPUs or share the GPUs, feel free to reach out and go to the Discord. Definitely all of us win in this kind of effort. And so, let's have the community come together. And if you want to connect, definitely connect with Ariel and other folks who work on this. We've talked about LoRa's, and we also saw from, I think, Tim Dittmer's, right? There's also a concept called QLoRa, and there's also fine tuning. And at some point, I saw at least Teknium say, enough. Teknium's in the audience, the green-haired avatar. I don't know if he wants to go. Teknium, feel free to. But to the top of the space, there's now pinned kind of a kick-off tweet that started a bunch of the ablation studies, as far as I'm aware, at least. That talks about, hey, let's get to the bottom of this. Like, what's the best method of doing fine tuning and extending, etc. And so I think this is kind of the start of ablation studies. I want to add Teknium to the stage. Teknium, feel free to introduce the kind of ablation studies and give us like a brief summary. And Jan, feel free to also kind of support when needed if Teknium goes too deep.
Okay. Basically, there's been a lot of debate about whether QLoRa's and LoRa's can be as good as a full fine tune. And a couple weeks ago, I tested Ouroboros's 7B model. He made a QLoRa and a LoRa and a full fine tune of those. And I found that the benchmarks were a bit worse on the QLoRa version. And I figured that there could still be other variables like hyperparameters and stuff like that could have caused the difference. So basically, I wanted to find a way to get a definitive answer because Tim's paper on QLoRa didn't really go as far as I wanted it to in terms of like comprehensively determining that it was equivalent. So I set up this experiment on Twitter where we're going to do sweeps, which is basically a bunch of different runs for the QLoRa, the LoRa, and fine tune, like the full fine tune, where it finds the optimal hyperparameters for 3 different data set types, like a small data set like LLaMa, a big data set like Hermes, and then like a task specific data set. I don't know, like a classifier or a sentiment analysis or something like that. And basically do sweeps on those to find the absolute optimum model that we can get from QLoRa, LoRa, and
Could you
full
explain
fine-tune.
the concept of sweeps for folks who never fine tune?
Yes. Well, we're also kind of new with sweeps. We've been working through a lot of issues to get them to work, but basically, sweeps will train the model automatically. Do well for the QLoRa's. It's like 180 runs that we have to do, where it's not the full training run, but basically it'll run through each of them until it hits an optimal point where whatever metric we're targeting starts to go in the wrong direction. And so we're doing a bunch of runs on the QLoRa,
until it finds the absolute optimal model that you can get with that data set. And we're basically doing that over LLaMa and a full fine tune. And then we plan to, once we find those optimal models, do a much more comprehensive benchmarking suite against each of those optimum models so that we can determine, hopefully once and for all, that LLaMa can be as good as full fine tune or not. And the different data set types is mainly so, like, maybe a larger data set is not good for doing LoRa's, but maybe a small data set like the Puffin data set, which is what we're using, that LDJ made, maybe a small data set like Lima style stuff is optimal to do a LLaMa or a LoRa with instead of a full fine tune.
Awesome. And so we're expecting great results from the study, and hopefully, like, I don't know if once and for all, because we may get like a LoRa. I already heard some other stuff. We also get new quantization methods that we've talked about, I think, yesterday, 2-bit and 3-bit, but we definitely don't have time to go into this because we want to start the interview. But folks who are interested in this study, feel free to maybe shout out how folks can help.
Mainly anybody who's done sweeps before, or anybody who can code like the trainers for Hugging Face Trainer and stuff like that to work on Axolotl to implement some of the things that we're trying to add to it. Those would probably be the best help right now.
You heard it here, folks. If you're interested in donating compute, or you're interested in helping Teknium alignment with Hugging Face trainers, Axolotl, and other implementations, feel free to reach out and go on their Discord and find them on Twitter. All of the links will be in the show notes. I appreciate your time if you made it all the way here, and thank you for subscribing to ThursdAI, and we'll see you next week. A brief mention of our sponsor, which we don't have. If you want to be, reach out to Alex. I would love to have this podcast sponsored so we can afford better equipment and better use of our time. With that, thank you.